Welcome to College Mathematics Made Simple. In this video, we want to find the derivative of the square root of 2x plus 3 using the first principles method and quotient rule. So we have the formula f prime of x is equal to the limit of that quotient as x goes to 0. So first of all, we are going to find this quotient. Where there is x, we put x plus h. So we have 2x plus h plus 3 minus the function f of x, everything over h. Now observe that the limit here, h goes to 0. But when h goes to 0 here, we have some number divided by 0, which is undefined. And so we are going to rationalize this expression so that we get rid of h in the denominator as follows. So we just multiplied this by the conjugate. But remember, in the numerator, you have the difference of two squares. So this is just the same as. Now the square root is just the same as the power of half. So half multiplied by 2 is 1. So that we have. Now we can distribute the negative and simplify. So you can see that 2x, you can see that 2x and 2x cancels, 3 and 3 is 0, and remain with 2h. Now h divided by h is 1. Okay, now we have the quotient. So this quotient here is the expression that we have in this box here. So we're going to take the limit operator as follows. So this is equal to, so when we apply the limit operator, this is 0. So we have 2 over the square root of 2x plus 3 plus the square root of 2x plus 3. But this is the same thing, so this is just twice, and this is 2 over twice the square root of 2x plus 3. The 2 and the 2 cancels, so that this becomes 1 over that, and we are done. Now we are going to apply chain rule, so we can write our function as y is equal to 2x plus 3 to the power 1 over 2. Now chain rule tells us that dy dx is equal to dy du multiplied by du dx. Okay. Now we're going to put u to be equal to 2x plus 3. This implies du with respect to x is equal to 2. Okay. So y is equal to, where there is 2x plus 3, we put u to the power 1 over 2. This implies dy with respect to u is equal to 1 over 2. Then we're going to reduce the power by 1, which is negative 1, negative 5. So this becomes negative 1 over 2, which we can just write as 1 over 2 u per half. Okay. So therefore, dy dx is equal to, we said du dy, and we said dy du. So dy du is that, so we can just write this as 1 over 2 square root of u, that is half, then multiplied by du dx is 2. So this 2 and this 2 cancels. Therefore, dy dx is equal to 1 over the square root of u, but u in this case is 2x plus 3. Then we are done. Next we are going to find dy dx given that x squared plus y power 3 is equal to 12. Now we are going to apply implicit differentiation. So in x, we differentiate it normally, which is just 2x, then plus. In y, we differentiate it normally, which is 3y power 2. Then we multiply it with the derivative of y with respect to x. Remember, y is a function of x. That is why we are multiplying dy dx by the chain rule. And this is equal to 0, the derivative of a constant. So therefore, 3y squared multiplied by dy dx is equal to negative 2x. We can divide throughout by 3y squared so that we have negative 2x divided by 3y squared, and we are done. Next, we are looking for dy dx given that x is t power 3 plus t to the power 2 and y is t squared plus t. So this is called parametric differentiation because we have different parameters. So we want dy dx, which will be given by dy, we are going to differentiate it with respect to t multiplied by dt with respect to x, which is just the reciprocal of dx dt. Now, dy with respect to t is just the same as, so we are going to take the derivative of y with respect to t, which is 2t plus 1. Now, we are going to take the derivative of x with respect to t, which is equal to, so this is x. Now, with respect to t, this is just a 3t squared plus 2t. Okay. Now, we're going to take the reciprocal of that, so which is just dt with respect to x is equal to, so which is just 1 over 3t squared plus 2t. Okay, we're just taking the reciprocal both sides. Thus, dy with respect to x is equal to, we said dy dt, and dy dt is 2t plus 1. Now we're going to multiply it by dt dx, which is just that fraction. So this is just over 3t squared plus 2t. And we are done. The last problem in this episode, we are looking for the equation of the tangent given the curve y is equal to x power 3 plus 2xy. The first thing is to find the gradient, which is the derivative of the given function at that point. So this is 3x squared plus 2 into 2x, right? Now it's at x is equal to 1, right? Because we have 1 comma negative 1. So therefore, the gradient m is equal to 3 multiplied by 1 squared plus 4 multiplied by 1. And this is just 7. So we have the gradient, which is 7. Now, we know that the tangent line is a straight line, which is given by y minus y1 is equal to m multiplied by x minus x1. So y1 will be equal to, this is 1 plus 2 into 1. This is power 3, power 2, which is just 3. Okay. So therefore, the equation is y minus, this is 3 is equal to m. M is 7 into x minus, and x value at that point is equal to 1. Okay. So we can expand, this is y minus 3 is equal to 7x minus 7, and this is just y is equal to 7x. This is negative 7 plus 3, which is negative 4. Thanks for watching. Please like, share, and comment, and tell us where you are watching from. Thank you.